Hi. Here is my lab number 3. The black hole motion. The point of this lab is to calculate a net force using motion data from a file given. This is different from previous lab there we predicted motion using net force. We will make a motion model and show net force and its parallel and perpendicular components. We also will calculate a mass of an object using universal Newton's gravitational law. The input file contains x and y positions of a star, measured with a time interval equal to 1 day. We assume the only force on the star is due to the gravitation of a black hole. The black hole has 0 coordinates position. The mass of the star is given. Now we have to edit the source code of the Python. We arrange a variable called black hole. We set up black hole position, star mass and time interval delta t. We import data from the file stardata.csv into list. We prepare 2 empty lists for x and y velocities. Using this while loop and loop variable index named x, we calculate x and y velocities for each delta t and store them in the lists. The velocities are displacement divided by delta t. Here is the main loop for the motion model. We compose initial and final velocities for each delta t. We calculate initial and final momentums. We calculate dp divided on dt. Here we use Newton's second law. Net force is equal to dp divided on dt. Here we calculate firstly, parallel net force using a unit vector of initial momentum and difference of magnitudes of initial and final momentum divided by delta t. We use Newton's second law again. Parallel net force is equal to dp parallel divided by delta t. We calculate perpendicular vector, dp divided by delta t subtracting parallel vector dp dt from net vector dp dt. And we use Newton's second law again. Net force perpendicular is equal dp perpendicular divided by dt. We are ready to run motion model. Yellow arrow is net force. Black arrow is parallel net force. Blue arrow is perpendicular net force. We calculate black hole mass using Newton's universal gravitational law. Here are Python code for calculation of the black hole mass. To be sure that nothing is wrong, I have printed black hole mass for each iteration of the main calculation loop. We see that black hole mass is a constant. Here are the question how forces are different from momentums divided by delta t. We answer is that we can observe motion and measure ratio, dp, dt if we knew mass of the object. We never can observe forces. The interaction is always invisible. Here is the question. Is it possible to find the mass of the new black hole that is different if the star motion remains unchanged? The answer is no. In motion data are unchanged. That means that interaction unchanged. So the net force will unchanged and we'll get the same calculation for the black hole mass. Thank you for your attention very much indeed.